So we want to touch on matrices tonight. Matrices is the plural of the word matrix, right? Word matrix. And just what exactly is a matrix? I'll give you a little technical definition. Uh-huh. Definitely. Uh, I love the things. Yeah. So a simple definition of what a matrix is. It's an array of numbers. It can be letters too, right? N rows and M columns. And usually you see them enclosed in a curved or square brackets, right? And you might very well have a capital letter to denote the matrix. Let me give you a little example. Why is that happening every time? So that's an example of one, right? This is what we call a 2 by 2 matrix. Right? It has 2 rows. Let me point out the rows. These are the rows. These are the columns. These are the rows. These are the columns. Right? Rows and columns. Sometimes you'll have what you call a. I find when I cut and bring over the thing, it looks nice, yes, but I'm getting some trouble moving it over. So you might have what you call a column matrix. Column matrix. And we're going to talk a lot about different types of matrices, right? So a column matrix basically, okay, let's name it C. The matrix looking like this. Maybe 3, 4, no? Just has one column, that's all, right? It can have any number of rows, but it has one column. That's a column matrix. Then you might have what you call a row matrix, right? Row matrix. So that one looks like that, right? Oh, by the way, I shouldn't have a comma here. I shouldn't have a comma. A space between is enough, right? No comma. When there's a comma there, you're describing a point, right? You're describing a point with the x and y coordinate, but this is a matrix, right? And you call it a row matrix because there's only one row. This one is a column matrix because there's one column. And you will hear about a square matrix. Square matrix. Matrix. That's basically a matrix. Okay, let's say you have 1, 2, 3, 1, or 3, 6. Okay, doesn't matter. So that's a 2 by 2. When the number of rows and the number of columns is the same, you can have 3 by 3 too. You can have 1, 0, 1, 1, 1, 0, 1, 0, 1. This is what we call a 3 by 3 matrix, right? These are all square matrices. The reason being, the number of rows equal to the number of columns. Follow that? And if you study matrices to this extent, you're not going to go very far with matrices. There's what you call the null matrix. Right? And that's the matrix uh, where all the elements are zero. You know, where you have a 2 by 2 like that, or you have a right? It has to be a square matrix in the first place, right? So, but all elements are zero. Next, we have what you call a unit matrix. Unit matrix. And again, this is a square matrix where all the elements of what we call the leading diagonal. This is the leading diagonal here. Right? Elements of the leading diagonal is 1. Right? You can have a 3 by 3, you can have a 4 by 4, and so all of them you can have. This here. Right? Both are unit matrices, right? This is a 2 by 2 unit matrix. This is a 3 by 3 unit matrix. Notice, this is what you call the leading diagonal, right? As a matter of fact, all unit matrices are diagonal matrices. Diagonal matrices are matrices where all the elements are 0 except the diagonal, right? Or what I call the leading diagonal elements, right? And they are, those can be non-zero, right? Like maybe you can have some like 2, 0, 0, 2, right? The diagonal, the leading diagonal elements are not 0. All the others are 0. The unit matrix is just a special type of diagonal matrix, right? And you might be wondering, what does this have to do with anything in the real world, But when you look at let's look at a little table, you know. You look at the table and you'll see that matrices, anything that can be data that can be stored inside of a table can give rise to a matrix. Right? We borrow one from here. That's difficult for me to draw all of this. Look at this one. Right? So these are some uh, some porcelains, and those are some things that they bought, right? And when you look at how the numbers are arranged, we can actually make a matrix out of it, right? We can make a matrix out of it. Right? You can actually formalize the matrix. That's the word they use. Right? And in the business world, let's say you have your inventory, and you're a businessman, and your inventory is on like a table. You could take that now and make it into a matrix and do a lot of calculations with it. Right? As a matter of fact, I'm teaching a course, business mathematics, and that's what I have to show the students, the application of matrices in the business world. Right? So I'm really not going to deal with too many of these applications because you are now being introduced to matrices, right? So we're not going to delve into too many applications, right? But so we want to delve into what we call matrix operation. That is how to add them, how to subtract them, how to multiply them. And while there's nothing by the name of division of matrices, we do have what we call the inverse of a matrix, right? So let's start with addition, right? Let's start with addition. Before you can add, two matrices can only be added if they have the same order, right? Two matrices can only be added if they have the same order, right? So keep that in mind. Let me just put a little note here. So notice that condition. If the two, when it's in the same order, the number of rows in the first must equal to the number of rows in the second. The number of rows in the, columns in the first one must equal to the number of rows in the second. Did I say that right? I didn't say that right. The number of rows in both matrices and the number of columns in both matrices must be the same, right? So if you have let's say a 2 by 3, you can't add that to a 2 by 2, right? You just can't add it. The second matrix has to be a 2 by 3 as well. It has to be a 2 by 3, right? If this one is a 4 by 4, It can be added to a 5, let me say a 4 by 5, right? It just can't be added. The reason why is that the operation of addition, you add corresponding elements. And if you have a 4 by 4, right? What happens to the fifth? Notice here, the fifth column, what are you going to add to that? You see? So for two matrices to be added, they have to be of the same order. So if you have a 4 by 4 here, this one has to be a 4 by 4. Or the other way around. If this is a 4 by 5, this has to be a 4 by 5. They have to be of the same order. I'll take an example. For whatever reason, I'm having a lot of mosquitoes around. Look at this example. Right, so matrix A and matrix B, right? A is that first one, B is the second one. Right? So you add corresponding elements, right? So you add 5 and minus 2, minus 7 and 4. That's what you see happening. 5 and minus 2. Okay, see. 5 and this 4. 8 and this minus 1. Here. 3 and 3. Here. And you simplify, right? 5 plus minus 2. Well, you're going to get 3. Minus 7 plus 4 will give you minus 3. 8 plus this minus 1 is going to give you 7. 3 plus the 3 is going to give you 6, right? That's how you add them. The subtraction is the same thing as well. Matrix subtraction. Same thing. Okay, same thing. We're looking for one that involves subtraction and not seeing the one that has the subtraction inside. The numbers are distorting. What's happening? Let me cut it there, nevertheless. Right, so I think what is happening here, this is supposed to be um, 3, right? This is 3. This is 8. This is minus 3, right? No, that's 3. So he's subtracting now, right? So minus 2 minus 5, that's what you see here. 4 minus 7, that's what you see here. Minus 1 minus 8, that's what you see here. 3 minus 3. That's what you see, right? And you simplify and you get that. So in matrix addition, you add corresponding elements. In matrix multiplication, you add, you subtract corresponding elements. That's all. Then let's deal with scalar multiplication. So in matrix multiplication, you have what you call scalar multiplication, right? Let me just click a piece here again. When you talk about scalar multiplication, it means you multiplying the whole matrix by some number in front, some constant. 1, 2, 5, minus 10, minus 1, some number in front. And to do scalar multiplication, you simply multiply the number in front by everything in the bracket. That's what you're seeing here, right? Maybe we can do a little example. Look at this one. So here we're saying that K equal 4, right? And you're given a matrix A that is minus 2, 1, 5, and 0. See? You're given this matrix and you're given K equal 4. So here you are multiplying A, which is the matrix, by K, which is K is 4 and the matrix is minus 2, 1, 5, 0. So you multiply this 4 by everything in here. 4 by minus 2 gives you minus 8. 4 by 1, 4. You don't have to do all this thing. You would watch the thing and do it. 4 by 5, 20. 4 by 0, 0. But if you want to do this step,
Excuse me, sir.
yeah.
Sir, is it necessary to put back the step or you can just work out and give the final answer?
But is that what I said? That's what I said. You
Oh,
don't,
sorry, I didn't hear
yeah,
you.
you don't have to put this in, right? Unless you have all the time in the world. However, you have what you call matrix multiplication, where two matrices are multiplied. And you have to brace yourself now, right? Because here's where some complicated operation is going to be shown to you, right? 1 second. So here, when you speak of matrix multiplication, I mean, no matter how much I read this, you have to see it explained with an example, right? What we basically do, we multiply the rows of the first matrix by the columns of the second matrix, right? And the funny thing, right? Funny thing is that there has to be a condition there's a certain condition that needs to be met before you can actually go about multiplying, right? Let me tell you that condition. Just like how remember with addition and subtraction, they had to be of the same order, right? So this here is the condition. They're telling you the two matrices are compatible for multiplication. Meaning you can only multiply them if the first matrix is of the order m by n, and the second matrix is of the order n by p. Now, one of the things I kind of disagree with what they're telling you here, right? In that it doesn't have to be p, or it doesn't have to be different, right? You can have two square matrices being multiplied, right? So in the square matrices, the number of rows and the number of columns is the same. Same thing here. But generally, take this for now, that these two numbers, the number of columns in the first must be the same as the number of rows in the second. That's the important thing, right? The number of columns in the first matrix must equal to the number of rows in the second matrix. And the resulting matrix that you will get will actually be the number of rows in the first one multiplied by the number of columns in the second. So this is something you'd have to remember. However, once you know matrix multiplication, it would be a problem, right? But at times you can be asked this, maybe as a recall something, right? Because some of you might be given two matrices and the order of the matrices are too large. If I give you 5 by 6, right? Multiply by 6 by 10, and I ask you, well, what's the resulting matrix? What's the order of the resulting matrix? You can't make couple matrices and multiply. You have to know, right, that if m by n is multiplied by n by p, the result will be an m by p matrix. That's what this whole notice is. As an example with some letters, let me show that up here. So let's say you're given A, and that matrix is A, B, C, D, right? And then another matrix B, E, F, G, H, right? And you want to find A multiplied by B. Matrix A multiplied by matrix B. How do you do that? So notice how it's done. They're telling you here, right? A, all right, let me go there. A by E plus B by G. Notice it there? You're multiplying this row by this column, and you're putting it here. Right? The first row by the first column gives you the first, well, this will be a number, right? A single number. We're doing with some real numbers as well. So let me erase that. Good. Next, we're going to multiply the first row by the second column, and that will give us this number. So A by F plus B by H, that's going to give you this number. Right? And there's no substitute for you trying plenty of these. Ready, go now? The second row by the first column will give you this number. C by E plus D by G will give you that. We begin, I don't want to go fast. We'll do examples just now with real numbers, right? And then lastly, you go with the second row by the second column, and you will get this number. And this is only 2 by 2 by 2 by 2. You can have some very big matrices. What I want to tell you, nobody does matrices by hand anymore, right? It's all computerized now. Watch it a little more. Rows by column, rows by column. And then we'll go to an actual example where we do the multiplication, right? Let's move it. Look at this. So you have a matrix A and a matrix B. Right? They're of the same order, so it's okay to multiply. Right? So let's multiply them. Let's multiply. Right? Let's do it by hand, right? You do it by hand so you don't get. Just put the answer all of one thing. So we multiply. We're multiplying this row by this column, right? So we're going to have 2 multiplied by -5 plus 3 multiplied by 0, right? So this row by this column gives you this. So next, we're going with the same first row but the second column, right? So 2 multiplied by 1 plus 3 multiplied by 2, right? That's this by this. Now we're going with second row by first column, right? -5 by -5 plus 4 by 0. Right? So that's this row by this column will give you this. Lastly, we're doing second row by second column, right? So negative 5 by 1 plus 4 by 2, right? And we simplify all of them. Simplify all, right? So we get what? 2 by minus 5 is minus 10. Well, that goes 3 by 0 is 0, right? The minus 10. What's this? 2 by 1, 2 plus 3 by 2 is 6. That's 8. 5 multiplied by minus 5 by 5 is positive 25. Hmm? And then this is what? Negative 5 plus 8 is 3. So that's your answer. Rows by columns, right? This row by this column gives you that. Fourth row by the second column gives you this one here. Second row by fourth column gives you this one. Second row by second column gives you this last one. You simplify all the arithmetic and you get it. Think you follow that?
Yes, sir.
Let me do another one. So this is a tricky one, so maybe this is something for you to remember. I'm going slow because this is something you have a matrix 2 minus 3, 4, 5. They tell you evaluate a square. Please do not make the mistake of thinking that a square means mosquito flying out. You all give me a second, right? Let me throw up the solution for you to see by the time. Meditate on it. Give me a second, right? But sorry about that, man. Yeah. So, as I mentioned, do not mistake a square to mean you square each element inside, you know? Square of 2 is 4, square of -3 is 9. No, don't think that. It simply means you multiply the matrix by itself, right? As you can see here, this row by this column, that's what it is here. This row by this column, that's what you see here. This row by this column, that's what you see here. This row by this column, that's what you see here. When you simplify it all, you will get it. Think you're following that?
Yes, sir.
Yes, sir.
You have to know basic matrix operations. Huh? Of course, as I told you, matrices is like one big topic in mathematics, right? So they're saying here, you have two equal matrices. Their corresponding elements are equal. Right? And sometimes you see this being used to solve equations. I'll give you an example. So when two matrices are equal, their corresponding elements are equal. That's what this means, right? Let's do an example. Let's look at an example here. I'll set all of this in some notes to you. I'll extract it from the textbook instead. You have this matrix, you have this matrix. They're telling you they're equal. And they want you to determine x and y. Well, as you see, x corresponds to -2 and y corresponds to 6. Simple as that. That's simple enough. Hmm.
Yes, sir.
Okay. Good. So let's take a pause there because I want to switch my notes here to some other operations with matrices, right? Take a little break. We come back at 7.